everyone, welcome back. It's great to have you here today. Today we'll be revising proof. We will be going through some examples together, so please get your pen and paper ready and work through these questions with me. So there are two techniques we are going to go through in this video. The first one is disprove by using a counter example. The second method is prove by using direct argument. So here's an example. First, we wanted to disprove that this statement is incorrect. So in the statement, it claimed that x squared subtract 1 is greater than 0 for any value of x. So what I needed to do to disprove it is simply pick a number to prove that it's wrong. So if x is 0, 0 squared subtract 1 is going to be negative 1, which is smaller than 0. Therefore, the statement is false. And this is as simple as this. As long as you can find an example to disprove this statement, then this proof is done. Okay, so now moving on to the next one, where we needed to prove using direct argument. So in the question, it says the sum of an even number and an odd number is odd. So an even number, we know we can write it as a multiple of 2, so 2n. An odd number is 1 more than an even number, which is 2m plus 1. Now, the reason why we wanted to use different letters here is because we don't have to have two numbers that are consecutive. So, for example, m can be 1, n can be 7. If we use the same letter, then that means n will need to be the same in both expressions. Okay, now in the question, it says the sum of these two numbers, so we are going to add them together. Now we need to prove that it's an odd number. Now if we can write it in the form 2 lots of something plus 1, then we can claim it's an odd number. So for this question, what we need to do is to factorize out a common factor of 2. So we have 2 lots of n plus m in the bracket, and then we have a plus 1. We leave that alone. We are not going to factorize out 2 from there. And this form shows us that this number is going to be an odd number. Therefore, we have proved the statement. So what I'm going to do now is to summarize the helpful expressions to help you with the proof. So if they are asking for an even number, then you know it's going to be 2n. Now you can use any other letters, 2a, 2b, doesn't matter. If it's an odd number, it's going to be 2n plus 1 or 2n subtract 1. So it can be 1 more than or less than an even number. A multiple of 3, so that's going to be 3n. So that also means that it is divisible by 3. So if we needed to write a number that is divisible by 3, we can also use this expression 3n. So these two are actually the same. If it's not a multiple of 5, so then that means it could be 1 more than multiple of 5, which is 5n plus 1, or plus 2, plus 3, plus 4. However, it cannot be plus 5. It's because you can factorize out a 5. Or it could be 1 less than 5n, 2 less than, 3 less than, or 4 less than. Similarly, if it says it's not divisible by 5, then you can pick any of these. These two are actually the same meaning. If they want us to write down two consecutive numbers, so that means the two numbers are next to each other, we can have n plus 1, or n minus 1n. If we want 3 consecutive even number, then we have to go from 2n to 2n plus 2. 2n plus 4. Or if we wanted to go backwards, we could have 2n subtract 2, 2n subtract 4, and 2n. Okay, now let's have a look at this final example. There is something that we need to watch out in this question. So in this question, we need to show that the product of two odd numbers is odd. There are two odd numbers. We know odd number can be written as 2n plus 1. Now, because we need two different ones, in this question, it didn't say two same odd number. We wanted to prove it for the general case. So we will need to use a different letter to say the other odd number, which could be done by saying it's 2m plus 1. Now the product, meaning that I'm going to multiply them together. If I expand the bracket, and I need to get into the form 2 lots of something plus 1. So the first 3 terms, as you can see, there is a common factor of 2. So if we factorize out 2, we would have 2 bracket 2mn plus m plus n. And then we have a plus 1 in the end, which is an odd number. Therefore, we have finished the proof. That is it for today. Well done for making it through to the end, especially if you have done these questions yourself. Remember, maths isn't a spectator sport, and we have to keep practicing to be better at it. Happy revising, and I'll see you in the next video.